everyone! Today we're going to be discussing a limiting reactant question.
So, what is a limiting reactant? The key point to understand is that the limiting reactant is used up entirely during the reaction, halting the process, and leaving some of the excess reactant remaining, but no more product can be formed when it runs out. Let's look at an example. Let's say you are making necklaces, and your supplies include string, beads, and metal plates onto which you glue the beads. If you only have 3 metal plates, the maximum number of necklaces you can make is 3, even though you will still have more beads and string remaining. In this case, the metal plates are the limiting reactant, the beads and string are excess reactants, and the completed necklaces represent the product.
Now let's try a problem that you might actually see on your chemistry test. The problem is, hydrochloric acid combines with calcium carbonate to produce carbon dioxide. If 50 grams of HCl reacts with an equal mass of calcium carbonate, what is the maximum mass of CO2 that can be produced? So the first thing we need to do to solve this problem is set up a balanced equation. And so we are given that hydrochloric acid combines with calcium carbonate, CaCO3, to produce carbon dioxide, which is the only relevant product in this problem, but it also produces water and calcium chloride. And so this is our entire equation, but we need to do one thing to balance it. And because we have H2O, we need to put a 2 here, and now also our chlorine is balanced because we have Cl2 over here. So we have 2 hydrogens, 2 chlorines, 2 chlorines, 1 calcium, 1 calcium, 1 carbon, and 3 oxygens. 2 plus 1 is 3. So this is our balanced equation. So this is a limiting reactant question. So we know that we have these 2 reactants, and one of these reactants is going to limit the amount of product that can be formed. So it's important to remember in this question that even though the problem says that we have 50 grams of both of our reactants, because the reactants have different molar masses, we're going to have different numbers of moles of each of the reactants. So what we're going to do is we are going to solve the problem for both of these reactants using mole ratios, and we're going to see which of the reactants produces a lower amount of carbon dioxide.
And that will be our limiting reactant.
We have 50 grams, so let's start with 50 grams all the way on the left. 50.00 grams of HCl over 1. So now we are going to use our molar mass of HCl to convert this to moles. Because what we really want to do is we want to be able to compare how many moles from the equation. We have a 2-to-1 ratio of HCl to CO2. So we need to be able to make that comparison, but first we have to convert to moles. So hydrochloric acid's molar mass is 1.008 grams for hydrogen plus 35.45 grams per mole for chlorine. And so that gives us a molar mass of 36.458 grams per 1 mole. So now you can see that our grams cancel and we're left with moles of hydrochloric acid. So now we can continue. So the next part of our equation is we want to use our mole ratio given to us in our balanced equation of hydrochloric acid to carbon dioxide. So let's start with, we want our hydrochloric acid moles to cancel out. So here we have 1 mole HCl. So now we're going to put our mole ratio, so we have 2 moles of HCl on the bottom. So moles of HCl are going to cancel. And for every 2 moles of HCl in this equation, we have 1 mole of CO2. So now our predominant factor is mole of CO2 because we first canceled out our grams and now we canceled out our moles of HCl. So now we're left with moles of CO2. And finally, what we want to do is we want to find grams of CO2 because the question is asking for maximum mass of CO2 rather than maximum moles. So for mass of CO2, we are going to do the opposite of what we did here, converting from grams to mole. We're converting from moles to gram. And so we need to use molar mass again. And so per mole of carbon dioxide, there are 44.01 grams, which is 12.01 grams for carbon plus 2 times 16 grams for oxygen. And so when we multiply this all out, we get 30.18 grams of CO2 when we're using how much HCl we have. Okay, now let's move down and do the exact same process for calcium carbonate. So we again have 50 grams of CaCO3. So we want to convert our grams to moles. And so for 1 mole of CaCO3, we have a mass of 100.09 grams. So now we're in moles of CaCO3. And so now we want to use our mole ratio, CaCO3 to CO2, to get our moles of CO2. And you can see that there is a 1-to-1 ratio of CaCO3 to CO2. And so technically this mole ratio isn't necessary because it's 1 mole per 1 mole. But it just helps us with understanding the concept of how to solve the problem. So we have 1 mole CaCO3, which cancels to 1 mole of CO2. So now we're in moles of CO2. Now our final step is we want to get into grams of CO2. So we do our molar mass. So 1 mole per mole of CO2, we have 44.01 grams. And now we're going to calculate that out. And when you multiply across and then divide, we will get an answer of 21.99 grams CO2. And so the answer that we are going to take is the lower answer because, as we can see, calcium carbonate is our limiting reactant because a lower amount of carbon dioxide is produced through the calcium carbonate. So in this reaction, the maximum, so theoretical yield of CO2 is going to be 21.99 grams. Thanks for listening. Hope to see you soon.